Good morning, one and all. In this class, we are going to study another type of flip-flop. First, I will just discuss about what is the drawback of SR flip-flop. Okay. Then after that, we'll study next flip-flop, JK flip-flop. Okay. Drawback of SR flip-flop. Very important. Two more question. Okay. So, what are the drawback of SR flip-flop? Main the drawback of SR flip-flop is obtaining an invalid state. Okay. Obtaining an invalid state. All of you observe that where we have got invalid state, actually when we are giving s equal to r is equal to 1, at that time we got q and q bar both are 1. So this is an invalid state. This never be a true form of output, and complement form of output will never be 1 at a time. Okay, so this is actually mainly the drawback. In order to eradicate this drawback, we need certain modifications. Okay, so which actually make the invalid state into the valid state. We have to do certain modification. That modification will be known as the JK flip-flop. Okay, so I've just started with the JK flip-flop here. The JK flip-flop, as I told, flip-flop is nothing else. It's a basic memory element, 1-bit memory element. Flip-flops are nothing else. It's just controlled by clock pulses. Okay, what is desired value has to be stored at the particular amount of time will be controlled by the clock pulses. Okay, so how the JK flip-flop looked is, what we have to do modification to my SR flip-flop so that I can obtain the JK flip-flop. Please see here. So as I know that my SR flip-flop looks like this. Am I correct? Just see here. This is my SR flip-flop. Okay, it has S, R, Q, Q bar. Okay, this is SR and there is a clock pulse. This is my SR flip-flop. So what modification I will do to this SR flip-flop so that I can obtain the JK flip-flop? Please check here what I am doing. Just simply I am modifying this way. I'll just this is my SR clock pulse. Okay, so see here what I am modifying here. I am just taking from Q bar and I'm bringing it to the input side and connecting to a AND gate and connecting to S. Okay. Similarly, I am taking another wire from the Q and bring it to the input, connecting it to another AND gate, and output is connected to R. Okay. So output is connected to R. Okay, and this will be my R now. Okay, so this is my J, this is my K. All of you understand what I have done modification? I have just taken a feedback path from Q bar and connected to the AND gate, and input will be J will be connected both the AND gates, and the output will be connected to S. Similarly K, Q. So what I have got here, I have modified my S input to J Q bar. Okay, and this is my Qn bar. Okay, so J Qn bar and R I have modified to K Qn bar. Okay, sorry, K Qn. Do you all understand or any doubts, students? So what I have done modification here, I am just having modification over here from the SR flip-flop connected to AND gates in such a way that I have got S input will be JQN bar, K input will be R input will be KQN. Okay, as I told you already, Qn is my present state, Qn plus 1 is my next state. Okay, so like this, what we are going to do, when the next state will come, whenever we will apply the clock pulse, this will next state will come. Whenever the clock pulse is not applied, that is called before application of the clock pulse present state, after application of the clock pulse present next state. Okay, so you see here next, what will be my logic diagram, logic design? As I told you, for all the 7 things you have to do for any type of flip-flop it will come. So what I have done, I have just taken SR flip-flop as it is. So SR flip-flop will be mine like this. Okay, so this is my SR flip-flop mainly, and here I have done one modification. This is my S and R, and this is my clock. So this is my SR flip-flop. Am I correct? So what I have done mainly here, I have taken a feedback path from here, from Q1. So this is Q1 bar, and I have bring this to here to input to the AND gate. Okay. Similarly, I have taken here another AND gate. Output will be connected here, and this I'll feedback to Q1. Okay, this much of modification I have done. Okay, so this is my logic design. Okay, do you all understand? And this is my JK flip flop. Now this SR flip flop, up to this it's SR flip flop. Now this modification is told as JK flip flop. So how it will be eradicate now my invalid state, we'll see now. Okay, so here what you have obtained, we have obtained that S equal to JQN bar, R equal to KQN. Okay, so this is the major thing. Okay, this is the modification we have done. Why we have done modification? In order to eradicate the invalid state. What is invalid state? My Qn plus 1, Qn plus 1 bar is not going to get 1 1. So I am not going to like get invalid condition which I am getting in the SR flip flop need to be eradicated. For that I have done certain modification like this. So see here how I am going to get the not getting the invalid condition. So that can be explained with the help of truth table. So the truth table looks like. So my truth table tells about the clock pulse, okay, and my J and K here input, okay. Next Qn also input. Why? Because Qn is feedback from here, okay. Qn bar is also feedback from here, so that's why Qn as well as Qn bar are my inputs, okay. Next S and R will be just modified. Of SC we have nothing else J Qn bar, R is nothing else K Q1. All of you understand? S is J Q1 bar, R is K Q1. Next, what I want actually, I want next state Q1 plus 1. So this is my output. So this is clock. If I'll apply the clock, I'll get the next step. Am I correct? So this is my JK, and this is my Q1 bar, SR, and this is my next state Q1 plus. Okay, so this is my next state. Next state. Okay, do you all understand? So see here what I am doing mainly. So this is my JK. Okay, so once clock pulse is not applied, so at that time whatever my JK, whatever my Qn bar, whatever my S and R, I will not get my next state output. What I will get actual next state output, whatever there in the memory element, the previous value I will obtain. Okay, do you all understand, students? Okay, if the clock pulse is absent, because I have told you flip flop is controlled by the clock pulse. If clock pulse is absent, whatever my inputs would be, I will get the previous value. Now if clock pulse is present, okay, now if clock pulse is present, so please carefully understand, students, very important concept I am telling here now. Okay, so if clock pulse is present, then JK, let's say my JK is 0 0. Okay, let's say somebody told that I am going to assume my present output, let's say 0 and 1. Okay, somebody will tell that, let's say sir, I will start assuming my present state output will be 0 and 1. Okay, somebody will tell that, sir, why I will not assume my present state output 1 0. Yes, you can assume. Okay, so there will be two cases can be come up for Qn and Qn bar. One is 0 1 and 1 0 for JK 0 0. Am I correct, students? Do you all understand? Somebody will tell that for JK input 0 0, I will take my present state output of the flip flop Qn bar would be 0 1, and somebody will tell that no sir, I can take 1 0. Yes, obviously you can take. There is a cases you can take. Now what will happen? So JQN bar means this is JQN bar, 0 and 1 AND gate. So it is 0, KQN, okay, 0 0, it's 0. Okay, so now tell me, if S and R 0 0, what I will get mainly? If S and R 0 0, what I will get mainly? Whatever the present state, that I will get, because My SR flip-flop truth table looks like this. SR Q1 plus 1, Q1 plus 1 bar. How it looks like? 0 0, I'll get previous value. Okay, 0 1, I'll get 0 and 1. 1 0, I'll get 1 0. 1 1, I'll get invalid state. Okay, so this is my SR flip-flop truth table. Okay, this can be obtained when application of the clock pulse. So I have applied here clock pulse. Am I correct? So I have applied here clock pulse, and my present state is what? 0 and 1. My previous value of the output is 0 and 1. So if I'll apply 0 0, what it will represent? It will represent the previous value of the output, which is 0. Okay, now so similarly here j qn bar, j is 0, qn bar is 0, 0 0 0 0 1 0. So again 0 0, what is the previous value I have? 1. Okay, so 0 1. So in this case, what you have obtained actually, whatever is my qn, the same thing I have obtained in these two cases. Okay, so can I say that this would be nothing else? My qn plus 1 is my qn. Do you all understand, students? Very simple. So in case of not application of clock pulse, whatever my input, I have got previous value. Next, when I clock pulse is applied and my present state is 0 and 1, 1 and 0, at that time if s and r will be 0 0, I have got the next state will be present state. So here I have got what? Next state, my qn plus 1 is nothing else, my qn. Am I correct, students? Now go for the next case. 1 0 1. Okay, let's say 0 1 is jk. Similarly, somebody will tell for this 0 1, I would have present state, let's say 0 1 or 1 0. Somebody will tell no sir, I will take 0 1. Somebody will tell I will take, assume initial present state will be 1 0. Yes, you can take. So j qn bar, where is j? My j is here. J qn bar 0 1 0 1 0 0. Next what is that? 0 0 0 1 1 1. Okay, so if it is 0 0, s and r 0 0, what I will get, students? I will get the previous value. So what is my previous value here? 0. The same thing I have got here. Okay, now s and r 0 1, what I will get according to the truth table? If it is 0 1, what is my next state? Next state is reset state, that is 0. So I have got here 0. So what do you understand from here? Whatever may be my previous state over here, I would be getting reset of my output in the next state. So I can say that this is combinedly 0, and this is also called reset state of my flip-flop. I have got for jk input 0 and 1. Okay, do you all understand? This is my previous value, this I have got here reset state. Okay, so now next. So very important, students, if you are not understanding this truth table, it's waste. You cannot understand next part. Please let me know if you are understanding or not. How will you understand? If you deeply come into this subject, then only will understand. It's very important subject. Without this, you cannot able to succeed in the EC branch. I'm telling you. Okay, so 1 0. Okay, now the jk is 1 0. So somebody will tell that, sir, I can take 0 1 my present state. Somebody will tell that for 1 0 input, I can take 1 0 my present state. Yes, you can take. So at that time, what is my jqn bar? Jqn bar 1 1 1 1 0 0 0. Next 1 0 0 0 1 0. Okay, so tell me now, if SR flip flop 1 0 combination, so what is my next state? Next state is 1. So I have got here 1. Okay, similarly 0 0 SR flip flop 0 0, what is my next state? Next state will be previous value. So what is my previous value here? My previous value is q1. So my previous value is q1, which is 1. So what do you understand from this? Actually, I have understood that for jk input 0 1, sorry 1 0, for jk input 1 0, whatever my present state would be, it just make my output to the set state. Okay, do you all understand, students? Very important. It just make the output to set state. Next, clock pulse is present. Let's say jk input are 1 1. Somebody will tell that I can take 0 1. Somebody will tell that for jk input 1 1, I can take 1 0. Next, what you have to do? jqn bar. So jqn bar 1 1 1, KQ1 1 0 0. Similarly, JQ1 bar 1 0 0 1 1 1. So at this case, what I have got 1 0 SR flip flop 1 0 1 0. At that time, what I have got 1. Okay, so it's just 1. Next for 0 1, what is my for 0 1 0. Okay, so what do you understand from this? I have got here what actually I have got. My Q1 is what? My Q1 is here 0 1, and I have got here my next state 1 0. Just the opposite. Can I say that this is my Q1 bar and this is another state it is? This is called toggle state. So what it is doing, whatever may be the previous output, it will just toggle if I'll give j and k equal to 1. So what do you understand from this? My invalid state during S and R equal to 1 1, I have got actually invalid state. But here, if I have modified my circuit and given 1 1 condition, I have got your toggling of output. So whatever my present state would be, that get toggled and I have got the valid output. So do you all understand how I have eradicated the invalid output to the valid output? So this is the way. So what I have done, I have just certain modification I have done. I have just introduced two AND gates at the input side and taken feedback and given to the J and K input. So here S and R equal to 1 1 never comes over here. Okay, anytime have you seen S and R 1 1 comes over here? So you can see where is my S and R. You have seen anytime 1 1 comes over here? No. Are you understanding? So we have eradicated that conditions with the help of this introduction of this modified circuit over here. Okay, so this actually tells me that how this is only the difference. This is only the difference between SR flip flop and JK flip flop. What it actually did, invalid condition of the SR flip flop has been brought into the valid conditions. Okay, so this modification, what it actually did, modification actually did the invalid condition in SR flip flop, invalid condition in SR flip flop has been brought back. Okay, has been brought back to the valid condition. So this is only the difference. So very important student in this concept. What is the difference between SR flip flop and JK flip flop? This is only the major difference. Otherwise, there is no much difference in it. Okay. So now, what is the main truth table of the JK flip flop? So I will just derive from this truth table the main truth table of the JK flip flop. So you can see. So my truth table here J K Q1 plus 1 next step after application of the clock pulse. Anyhow, clock pulse I have applied here. Okay. So 0 0. What I have got for JK flip flop 0 0, I have got previous state. So we can write down here previous state is what? Q1. Okay. Whatever there in the before application of the clock pulse, I have got after application of the clock pulse also same if I have applied JK 0 0. Now JK 0 1. What I have got? I have got the reset state, that is Qn plus 1 is 0, that is called reset state. Okay, and this is previous state. Okay, next to 1 0, I have got 1, that is called set state. Next to 1 1, it is toggle state Q1 bar. This is only the difference between SR flip flop and JK flip flop truth table, nothing else. Everything else is similar, only I have got this particular thing extra in case of JK flip flop, nothing else. Okay, all of you understand? So this is my truth table, which is third number. Okay, now is there any doubt, students? Please unmute and ask me if you have any doubt. Any doubt? Please let me know, students. Any doubt? If there is no doubt, I'll just continue, students. Okay, so fourth one, I have told you characteristic table. We have already discussed the characteristic table of a SR flip flop. Now, how to develop the characteristic table of a JK flip flop, we'll see over here. Okay. So, as I told you, characteristic table has what actually it actually told. Actually, it told about with the presence of input JK, how there is a state transition from the present state to the next state. Okay. So, what are the inputs in the characteristic table? Mainly Q1, J and K are my inputs. Okay, do you all understand? And what are my outputs? My output will be next state, which is Q1 plus 1. Okay, so this is my characteristic table tells about. So this is 3 variable 2 to the 3 8 number of combinations possible in the characteristic table. So what are those? 0 0 0. Please try to understand those who are absent in the previous class. 0 0 1 0 1 0 0 1 1 100 101 110 next 111. So these many 8 combinations possible. Apart from that, nothing is possible. Now you can see how I have derived yesterday the characteristic table from the truth table only. Am I correct, students? So what I have done, please check here. So what is my JK flip flop truth table? My JK flip flop truth table looks like this: Q1 plus 1 0 0 Q1 0 1 0 1 0 1 1 1 Q1 bar. Okay, so this is my truth table. With the help of this only I am going to do. Please check here. If it is not understanding, please ask me. So here you can say my JK00 and my this is my what present state. Okay, before application of the clock pulse. This is what next state after application of the clock pulse. So now clock pulse is applied. That's why I want my next state to be get. Okay, so 0 0. What is my output actually for 0 0 in next state will be Q1. So what is my Q1 over here? 0. So can I write down 0? Okay, so 0 1 at that time it will not bother about what is my present state. It will just reset my output. So this reset 1 0 it will just set 1 1 it will just toggle. Are you seeing 1 1 it will just make Qn bar. So my Qn is 0 it will just make my Qn bar. Okay, are you getting any invalid or don't care condition over here? No. Okay, so this is my previous state, this is my reset state, this is my set state, and this is my toggle state. How I have observed, do you understand? So now 0 0 again previous state 1, next to 0 1 reset, 1 0 set, 1 1 toggle. Okay, Qn bar. Okay, so like this I got, this is my characteristic table. Okay, do you all understand how I have got? I have just seen my truth table and what is my present state, accordingly I got the next step, nothing else. Okay, so now after characteristic table what you need to do? You need to find out the characteristic equation. So how to find out the characteristic equation? The characteristic equation can be derived from the characteristic table. If you can solve this characteristic table using KMF, you will get the characteristic equation. So obviously it has how many variable? It has 3 variable. What are those variables, students? Simple. The variables are Q1, sorry, J and K. Okay, Q1, J and K. So here how many cells will be required? Three variable, 8 cells are required. So these are my 8 cells. So J bar, K bar, J bar, K, JK, JK bar. This is my Q1 bar, Q1. And what are my place values? 0 1 2 3 4 5 6 and 7. Okay, so according to this I am just going to put those values. So these are my min term 0, min term 1 2 3. So I'm just put those values 0 0 1 1. So I'm just going to put here 0 0 1 1. Next 1 0 1 0 1 0 1 0. Do you all understand or any doubt? So now we start grouping. So grouping, one grouping would be like this. It has a pair. Next another grouping, can I do it like this? Yes. So what I have got here, from this I have got J Qn bar. From this I have got K bar Q1. Okay, so what is the characteristic equation of the SR flip flop, JK flip flop? Qn plus 1 is J Qn bar plus K bar Q1. Very important, students. Characteristic equations. Okay, next after characteristic equation what you need to do? You need to have to find out the state diagram. State diagram is what I have told you already. The state diagram, the state diagram is nothing else how the state transition in presence of my flip flop inputs. Okay, so this is my state diagram. So in the state diagram, I have already told you a flip-flop has two states. What are those states? The states are 0 and states will be encircled by this 0 and 1. Two states and these states are encircled by circle. And there will be state transition from 0 to 0. There will be state transition from 0 to 1. There will be state transition from 1 to 1. And there will be state transition from 1 to 0. Okay, state transition will be represented with the help of arrow mark, and it has a origin and it has a end point. Okay, so the state transition always from present state to next state. So see here, if the state transition is 0 0, so what are the cases from the characteristic table? Here in this case, state transition from 0 to 0. Are you seeing why? Present state is 0, next state is also 0. So state transition from present state to next state. Always state transition from present state to next state. Here present state is 0, next state also 0. Any other case? Yes, this case also. Present state 0, next state 0. So at that time, what is my J and K? My JK is 0 0 0 1. So I'll just going to write down here my JK is 0 0 0 1. So you can see here 0 is fixed for J, but K sometime it's 0, sometime it's 1. So I can end up with 0 and don't care. Okay. Now I'll see what are the state transition from 0 to 1. Okay, where the state transition from 0 to 1? You can see here the state transition from 0 to 1 is here, as well as state transition from 0 to 1 is here. Okay, at that time, what is my JK? My JK is 1 0 and 1 1. Are you understanding? So my JK is 1 0 and 1 1. So I can make this J as 1 and K will be sometimes 0 and 1. So I can make it 1, don't care. Okay, now state transition from 1 to 1. So in this case, the state transition from 1 to 1, where it is state transition from 1 to 1? This is one case where state transition from 1 to 1, and this is another case where state transition from 1 to 1. Okay, at that time, what is my JK our inputs? 0 0 1 0. Okay, my JK inputs are 0 0 and 1 0. So I can write down here, this is my don't care, this is my 0. Okay, do you all understand? Now state transition from 1 to 0, where is the case state transition from? Okay, where is the case state transition from 1 to 0? This is the case where state transition from 1 to 0, and this is the case where state transition from 1 to 0. Okay, at that time, what is my JK? 0 1 and 1 1. So you can see here my JK will be 0 1 and 1 1. So I can write down here don't care 1. So finally, the state diagram we have achieved like this. Okay, do you all understand how the state diagram I have made? Now, the last part of it. Excitation table. I have already told you excitation table. What is the excitation table? How the state transition in presence of the flip-flop inputs. So here in the excitation table, we have inputs Q1, Q1 plus 1, and J and K are my outputs. So you can see 0, 0, 0, 1, 1 0 1 1 1. How we can find out JK? From here, 0 0 state transition from 0 to 0. So what is my JK? 0 don't care. So this I am going to put over here, 0 don't care. Now 0 1 0 to 1, at that time what is my JK? 1 don't care, 1 don't care. Next to 1 0 1 0 means state transition from 1 to 0. What is my JK? Don't care, 1. Now 1 1, what is my JK output? Don't care, 0. Okay, so this is very important, student. This is my excitation table of the JK flip-flop. So you need to remember these excitation tables. Okay, because if you know this, you can able to do the next part, which is called flip-flop conversion. Okay, if you know the excitation tables, then only you can able to do that. Otherwise, no. Okay, now next part, another flip-flop. So here, what is the problem? I'll tell you later. And next, I will explain you MSJK flip-flop later. Okay, those things. Before that, I am just explaining you another type of flip-flop is called delay flip-flop. Is also called D flip-flop. Many names of it there. Okay, is also called transparent flip-flop. In exam, anything can come up in the exam. Please remember all these names. Apart from that, some three, four more names are the data flip flop like this. Okay, so D flip flop, delay flip flop, transparent flip flop, very very important students. Many applications you can do with this flip flop. Okay, so mainly what we have to do here, the logic symbol is here. The logic symbol is just we are going to take SR flip flop as it is. Okay, and here what modification we are doing, just I am making a not get between S and R, and I am giving here as a D. So this is my S R and clock is as it is, and this is my Q N Q N bar. Okay, do you all understand? So what I have done mainly here, I have just put a not gate between S and R, and this conversion we make it to the D flip flop, delay flip flop, or transparent flip flop. Okay, so now how it works, I'll tell you, don't worry. Okay, so now logic diagram or logic design. So very simple logic design. You know the SR flip flop, how the SR flip flop is very simple. It has 4 NAND gates. Okay, and there is a feedback path always. Okay, and there is a clock pulse. Next, what I'm doing here, I'm just putting a NOT gate between S and R to make it to D flip flop. Okay, this is my SR, this is my Q1, Q1 bar. Okay, do you all understand? So this is my logic design. Now, what is my truth table for delay flip flop? So see here what I'm doing, I have input D, and what would be my S and R at that time, and what is my Qn plus 1 next state. I want to see next state. Okay, so let's say here you can see my D is, let's say, 0. If D is 0, D is directly connected to S, so S also 0, and D bar will be R, so it is 1. So now tell me, for S and R 0 1, what would be my next step? Next step will be reset state, because R is reset, so it make my next state to reset state. Okay, now D is 1. If D is 1, S is D, so 1, and this is 0. So 1 0 at that time, what is my, it is just set my flip flop output. So what do you understand from these ones? So what we have understood from there, whatever that D will be, the same will be the next step. Okay, so we can understand from here that D just Qn plus 1, the next state just follows the D. This is 0 1, this is also 0. That's why it's called transparent flip flop. Whatever will give input here, the same output will get at the next output. Next state output will be same after application of the clock pulse. If you put 0, it will get 0. If you put 1, it will get 1. That's why it's called transparent. Do you all understand why it is called transparent? Because the next state output follows the present input, nothing else. Okay, so now do you all understand? So this is the truth table of delay flip flop. Okay, now, so the question is, why we need such delay flip flop? Why we need delay flip flop? Obviously, tell me, why we need delay flip flop? Because in some time we want my output is ready, but we don't want the output at the same time. We want the output after, let's say, 40 nanosecond of time. So what you need to do, give some clock pulse of 40 nanosecond to the delay flip flop and put D equal to 0. It will not show your output. Okay, so we can apply some delay to the circuit through the delay flip flop. Okay, that's why it's called delay flip flop. And why it is transparent? Because the output present, sorry, next state is following my present state input. Okay, that's why it's called delay flip flop and transparent flip flop. Now the characteristic table. So what is characteristic table? The characteristic table has Q1, D, and Qn plus 1. Am I correct? Okay, so here I would have how many combinations? 2 inputs, 2 to the square, 4 combinations, 0 0 0 1 1 0 and 1 1. So obviously Tell me what I have told you. Whatever the D, the same will follow. This will they will not check the what is the next present state. They will the next state will just follow the input D. So this is 0 1 0 1. It will not check whatever may be my previous output. Okay, it will just follow the my present input T. Okay, so what will make characteristic table? If you draw the K map also, the characteristic equation will come. How it will come? Qn plus 1 will be your D. Okay, so this is my characteristic. If you can do that using kmap, it's a two variable kmap, you can do it qn and d. So this is d bar d, qn bar qn, and this is your 0 1 0 1. Just you can see, do it like this. So you can get my qn plus 1 is d, and from the truth table also you can see my qn plus 1 is d. Am I correct, students? It's just following whatever I am d input, the same thing I am getting at the next state output. Okay, do you all understand or any doubt? So all of you understand the characteristic equation, how I have got qn plus 1 is d. Okay, so now state diagram. State diagram. What is state diagram? I have told you already, a flip-flop has two states, 0 and 1, and the state transition will be shown by the arrow mark. So either there will be state transition 0 to 0, either there will be state transition 0 to 1, either there will be state transition 1 to 1, either there will be state transition from 1 to 0. Now tell me, if the state transition from 0 to 0, where it is the state transition 0 to 0 here, at that time what is my d? 0. So what do you understand from this? Whatever the next state is here, next state is where? 0. The same thing will come over here. Here in this state transition, what is next state? 1. So my D will be 1. Okay. Here the state transition will be 1 to 1. So my D will be 1. Next state is 1. Here state transition from 1 to 0. The next state is 0. So do you all understand? This is my state diagram. Okay. Very simple. Because Q1 plus 1 is D. So here origin is Q1, Q1 plus 1 is endpoint. So where the endpoint is going, the same thing will be come in the D. Okay. So this is my state diagram. Next. After state diagram, what you have to do? Excitation table. So what excitation table tells? Excitation table tells that how the state transition from the present state to next state in presence of the flip-flop input. So here Q1, Q1 plus 1 are my input and D will be my output. Okay, 0, 0, 0, 1, 1, 0 and 1, 1. So what will be my D, students? D will be just follow the next state. So this will be 0, 1, 0, 1. Okay, so no need to remember excitation table. It's very easy. You know that my Qn plus 1 is D. So D is also Qn plus 1. That's why I have just done like this. Okay, very simple. So this is my delay flip-flop. Okay, any doubt on this, students? Do you all understand the delay flip-flop or any doubt? So what I have done, I have just modified the circuit like this to get access of this way. So where I need some delay in the circuit, I can introduce a D flip-flop and I can give certain clock pulses of delay. Okay, so this is the basic requirement of the delay flip-flop, and it will be very useful. We are going to use many times in the counter, shift registers and all. I'll tell you in the fourth chapter. Okay. Now next flip-flop, fourth number flip-flop is T flip-flop. T flip-flop is also called toggle flip-flop. Do you all understand, students, whatever I have told? Two flip-flops I have discussed now, JK and D. Very, very important. Whatever I am telling, please try to understand those things well. Okay. So now, for the T flip-flop, what you have to do? Which flip-flop will take to modify to get the T flip-flop? So where we are getting mainly toggle, students, do you all understand? In the JK flip-flop, we are getting toggle. When we are getting toggle, whenever I am applying J equal to K equal to 1, I am getting Qn bar, which is Qn plus 1. Okay, I am getting next state output will be toggle when I am giving J equal to 1, K equal to 1. Okay, so toggle flip-flop can be designed from where? Toggle flip-flop can be designed from the JK flip-flop. Okay. So see here what I am doing, my logic symbol will be J. I have taken a JK flip-flop. Okay, and this is my JK. Okay, and this is my clock. And what I have done here, I have taken it and sorted these two, and this is called T. Okay, and this is my Q1, and this is my Q1 bar. So this much of modification, which gives me the T flip flop. So what I have done here, when I will get toggle state, first of all, whenever T equal to 1, I have got toggle. Okay, J equal to 1 equal to K. Okay, so what I have done here, what modifications I have done here, very simple. So which can be designed with the help of logic design here. So the logic design will be, I know how to design the JK flip-flop. So first I can draw the SR flip-flop. From the SR flip-flop, I will do little modification to get the JK flip-flop. Then I will do little more modification to get the T flip-flop. My correct friends. So this is my S and R flip-flop. Now I can have one more AND gate here, one more AND gate here, and this input I have taken from here. Okay, this input I have taken from here. Okay, and this will be my J, and this will be my K. Now what modification I will get to get it T flip flop? I'll just take in this and sort both of this, and this become my T flip flop. Very simple. Up to this it is SR, after that JK, after that T. If I just sort J and K to get the T flip flop. Do you all understand? So very important. This type of circuits you need to understand well. Okay. So this is my logic design. Okay, this is my logic symbol of T flip flop. This is my logic design of T flip flop. Okay. Now third part, how to find out the truth table, how to construct the truth table. Okay, the truth table has how many inputs here? T. If my T equal to, so now tell me, so how the T will be, where the T will be connected over here? T will be connected to my J and K. Am I correct, friends? My J. Okay. So mainly where the T is connected, T will be connected to here and here. What is the output here? Output is S and R. So I can take S and R. So S is what actually? S is nothing else my T and Q1 bar. And what is R? T and Q1. Am I correct, students? So here if I put T equal to 0, so what I will get over here? S and R. If I'll put T equal to 0, one of the input to the AND gate is 0, means S will be what actually? 0. Okay. If this also 0, one of the input to the AND gate is 0, then what I'll get? R is also 0. Now tell me, for S and R 0, 0, what I'll get? I'll get the previous value. What is previous value? Q1. Very simple. Now if T equal to 1, now if I'll Q T equal to 1, here also 1, here also 1. Okay. Now if it is 1, what it will do? It depends upon the my, if any of the input is 1, it depends upon my previous sorry, another input. Let's say my another input is here also 0. Okay, so here it is 0, Q1 is 0, and you can see my Q1 bar is 1. So at that time what I will get? S and R I will get 1 1. Okay, so I'm getting 1 1. For that case, if 1 1, so what I will get here? Toggle. Do you all understand, students? Sorry, I have made a small mistake here. This will be my JK, not S and R. Okay. Okay, do you all understand? So what I have done here, T equal to 1, my J and K equal to 0 0. T equal to 0, my J is 0, K is 0. So at that time, what is my truth table of JK tell? My truth table of JK told that if it is 0 0, it is just Q1, 0 1 0, 1 0 1 1 1 Q1 bar. So you can see my T equal to 0, what I will get? JK both 0 0. If both 0 0, what is my output? Q1 plus 1, it is Q1. Okay, similarly T equal to 1, what is my JK? 1 1, which is Q1 bar. I have got JK 1 1, which is Q1 bar. So this is the truth table of the T flip flop. So what do you understand from this? T Q1 plus 1, I have just shortened the truth table here. So T equal to 0, I have got Q1. T equal to 1, I have got Q1 bar. Okay, so this is the truth table. Now, do you all understand or any doubts, friends, how I have got truth table? I have put here t equal 0, j equal 0, k equal 0, and I know that for j equal 0, k equal 0, it is previous value. Okay, previous value. So what is previous value? Previous value is q1, that I have put over here. Now t equal to 1. If t equal to 1, j equal to 1, k equal to 1. J equal to 1, k equal to 1. I know that what is my next bit. Next state is q1 bar toggle. So I have got here q1 bar. And next I have shortened it, nothing else. I have just removed jk and I have just put it into t and q1 plus 1. Okay. Now characteristic table. All of you understand this? How I have constructed the truth table? Okay. Next it would be characteristic table. So the characteristic table tells us the state transition from present state to next state in presence of the input. So input will be q1 and t, output will be q1 plus 1. Here this is present state, here this is next state. Next state will be obtained after application of the clock pulse. Okay. So now if it is two inputs, it has four different combinations 0, 1, 1, 0 and 1, 1. Now tell me, for t equal to 0, what is my out next step? For t equal 0, next step is previous value. So what is previous value? It is 0. For t equal to 1, what is my previous value? Next step, q1 bar. q1 bar means it is q1, q1 bar is 1. Are you understanding? So t equal to 0, previous value. T equal to 1, toggle. Okay, so this is my characteristic table. Now, how to derive the characteristic equation? The characteristic equation by looking into the two table. Characteristic equation, how it will be? q1 plus 1 looks like q1 xor t. This is the truth table of the xor gate. Am I correct? So my characteristic equation will be q1 xor t. Okay, do you have any doubt? You can also do with the kmf, you will get the same thing. Okay, now sixth one, state diagram. So what is state diagram? I have already told. A flip-flop has okay. So what is state diagram? I have already told you a flip-flop has two states. What are those? 0 and 1. Okay. A state transition will be derived with the help of arrow mark. Starting, this is present state and going to the next state. Okay. Origin is present state, end is next state. Okay, there may be state transition from 0 to 1, there may be state transition from 1 to 1, there may be state transition from 1 to 0. Now at that time, what is my t? That I need to find out. So state transition from 0 to 0, this is the case. So what is t? T is 0. State transition from 0 to 1, what is the case? State transition from 0 to 1, this one. What is t during that time? 1. Okay, t is 1. State transition from 1 to 1, what is the case? State transition from 1 to 1. So this is the case. What is t at that time? 0. State transition from 1 to 1, t is 0. State transition from 1 to 0, where is it? State transition from 1 to 0, t is 1. Okay, t is 1. So this is my state diagram. Understand? Now at the end we are going to find out the excitation table. So the excitation table is nothing else, how the state transition in presence of the flip-flop input, which is nothing else, my q1, q1 plus 1 is my inputs and t is my output. So you can see q1, q1 plus 1. q1 is here present state, next state is q1 plus 1. So q1 0 0 0 1, it may be 1 0. State transition from 1 to 1. So if state transition from 0 to 0, what is my t? T is 0. State transition from 0 to 1, what is my t? T is 1. State transition from 1 to 0, what is my t? T is 1. State transition from 1 to 1, what is my t? 0. Okay, you all understand? So this is the characteristic excitation table. It's very peculiar thing that here you can see in D flip-flop and T flip-flop, you can observe that characteristic table and excitation table are almost similar. Okay, do you all understand, students? Very important. So this is the thing, characteristic table and excitation table are equal. Okay, so now without wasting time, I'll go to the next part. So if you are not understanding, it's tough, students. I'm telling you. Do you all understand the flip flop whatever I've told till now, or any doubt? Please let me know immediately. Any doubts, students? Please, someone unmute and ask me if there is any doubt. Till now, we have discussed all the flip flops. Only one flip flop is left out. That I will tell you later. Okay. And user defined flip flop also I'll tell you later. Don't worry. Later means in the next class. Okay. So any doubt? Sriram, did you understand? Sriram Murthy, did you understand? Hello, Sriram Murthy, are you there? Sriram Murthy, are you there? Okay, you got your wish, students. I cannot do anything. I can give my effort to make you understand. But if you cannot understand net, like you cannot listen to it, what I can do? I cannot do much. Okay, your wish. So anyhow, Sriram Murthy, are you there, or I'll just remove you from the class? Are you there, Sriram Murthy? Okay, I'm removing you. Bye bye. Have a nice day. Hasini, did you understand?
Yes, sir.
Okay. Vamsi, B. Vamsi Nived. Did you understand?
Yes, sir.
Okay, good. Okay, so I'll not waste time. Okay, so we'll go for the next one. Next one is very, very important. How to set initial condition to flip flop. What is that meaning? So, till now I have told you, students, I am assuming something my output Qn and Qn bar. Qn and Qn bar, I am assuming 0, 1, 1, 0 like this. But is it in real case like this? No. You have to set initial condition, some extra circuitry. With the help of extra circuitry, you can have to set Qn and Qn bar 0 and 1, 1, 0, 0, 0, 0, 1, whatever may be. You have to set it, set the initial condition. How? We can see here. Initial conditions are applied to the before applying the actual input conditions. Okay. So first what you need to do, you have to apply the initial conditions before application of the actual condition of the flip flop, actual input condition of the flip flop. What are the input conditions for SR flip flop? What are the input conditions? You are giving S equal 0, R equal 0. You are giving S equal to 0, R equal to 1. You are giving S equal to 1, R equal to 0. You are giving S equal to 1, R equal to 1. These are the actual input conditions. Actual input conditions. But before applying these input conditions, you have to first make these outputs assumed, these two outputs 0, 1 or 1, 0. How? This will be done with the help of this particular circuitry. I will tell you now how you have to make it. So initial condition, this is called initial condition. So initial condition of the flip flop, you have to apply to the flip flop before application of the actual inputs. So these are actual inputs. So before that, you have to apply certain conditions to the flip flop, initial conditions, that is called, before application of the actual input conditions. Okay. So initial condition is nothing but the initial state of the flip flop. So initial condition is nothing else, is nothing but the initial state of the flip flop. Okay. In state of the flip flop. Okay. Do you all understand? Next, in order to specify the initial condition, two additional inputs you have to add. So what are those additional inputs? Two additional inputs we have to require to set the initial condition. What are those additional inputs? One is called preset, is also called PR. Okay. And another input condition is clear and CLR. Okay. So in order to get the initial condition, you have to take two extra additional inputs to the flip flop. These are called preset and clear. How to Way to apply this preset and clear, I'll tell you, don't worry. So preset is used in order to set the flip-flop. So now the thing is, preset is used in order to set the flip-flop. So now the question is, what is set the flip-flop? What is set the flip-flop? You have to make q equal to 1, q bar is 0. That is set the flip-flop. Understand? Means before application of the actual input. So I am telling you, students, I am assuming something qn and qn bar. What is that? I am applying certain preset and clear conditions to get this qn. So now I am assuming, I told assume. Assume means what you have to do? You have to apply some preset condition to get this data thing. Okay, next, set clear will be used in order to reset the flip-flop. Clear will be used in order to clear the flip-flop or reset the flip-flop. Okay, what is reset the flip-flop? Reset the flip-flop means q equal to 0, q bar is 1. Okay, you have to make clear to the initial conditions so that it will make q equal to 0 and q are equal to 1. Now, how I am going to use it? Please check here. Let's say I am taking a SR flip-flop. Consider SR flip-flop with preset and clear conditions. Preset and clear. So how the circuitry? Please check it. Okay. So this is my SR flip-flop. All of you understand that this is very important. This is my SR flip-flop. This is very important, students. If you do not understand this, next class it will be tough for you. Okay. So this is my SR flip-flop. Am I correct? Okay. And this is my clock pulse. This is my SR. So my preset and clear where? Here. This is PR. This is CLR. Okay. This is Q bar. Okay. So SR flip-flop with preset and clear condition. Okay. Don't worry. Anyhow, for today's class, this much only. This circuit I will analyze in the next class. How I am getting the initial conditions 0, 1, 1, 0, whatever may be, I'll tell you in the next class. What is the condition I have to apply? So before application of the real input S and R, what I have to give to this preset and clear, what I have to set up to this preset and clear, so that I'll get initial condition 0, 1 or 1, 0. That I'll this analysis I'll do for you in the next class. Okay. So any doubt, please let me know immediately. Otherwise, I'll just end up the class over here. Any doubt, students?